Welcome to Knowledge Bites, your daily dose of wisdom.
Henry Becquerel, the accidental discovery that lit up physics. What if I told you that one of the most transformative discoveries in science came about because someone forgot to put an experiment in the sun? Strange but true. Henry Becquerel, a French physicist with a passion for light and its mysteries, stumbled upon radioactivity in one of the most serendipitous accidents in scientific history. But let's not get ahead of ourselves. This story is worth savoring from the beginning. Becquerel was born in 1852 into a family that seemed to have science written into its DNA. His grandfather studied electricity and luminescence, and his father was a professor of applied physics. It's no surprise, then, that young Henri followed suit, pursuing studies in engineering and physics. By the late 19th century, he was a respected scientist, working at the prestigious École Polytechnique in Paris. The late 1800s were an electrifying time for physics. Scientists were uncovering the secrets of light, electricity, and magnetism. One of the big questions of the day was, how does light interact with matter? Becquerel, fascinated by this, focused his research on luminescence, the property some materials have to glow after being exposed to light. Think of glow-in-the-dark toys, and you'll have an idea of what intrigued him. In 1896, a groundbreaking discovery shook the scientific world. Wilhelm Röntgen had just discovered X-rays, those mysterious rays that could pass through flesh but not bone, revealing the hidden skeleton within. Inspired by Röntgen's work, Becquerel wondered if there might be other, invisible rays out there waiting to be discovered. He turned his attention to phosphorescent materials, particularly uranium salts, which glowed in the dark after exposure to sunlight. Becquerel's plan was simple. Expose uranium salts to sunlight, place them on photographic plates wrapped in black paper to block visible light, and see if the salts emitted rays that could penetrate the paper and fog the plates, much like X-rays. At first, his experiments seemed to confirm his hypothesis. The photographic plates showed fogging, suggesting that the uranium salts were emitting some kind of mysterious radiation. Then came the twist. In late February 1896, Paris was unusually cloudy. Without sunlight to expose the uranium salts, Becquerel decided to store them in a drawer alongside the photographic plates. A few days later, he developed the plates, expecting to see nothing. To his astonishment, the plates were fogged just as strongly as if they'd been exposed to sunlight. This meant the uranium salts didn't need sunlight to emit radiation. They were doing it all on their own. What Becquerel had discovered was a natural, spontaneous emission of energy from uranium atoms. This was radioactivity, though the term wouldn't be coined until later by Marie Curie, one of Becquerel's greatest admirers and collaborators. It's worth noting how groundbreaking this was. Until then, atoms were thought to be indivisible, the fundamental building blocks of matter. Becquerel's discovery hinted that atoms had an internal structure and could undergo transformations, releasing energy in the process. But let's put this discovery into context. Imagine you're holding a flashlight, expecting it to work only when you switch it on. Now imagine finding out that the flashlight glows all the time, even when it's off, because its batteries are producing light spontaneously. That's essentially what Becquerel had found, an energy source that seemed to defy all known laws of physics. Becquerel's work laid the foundation for the atomic age, but he wasn't a flashy figure like Einstein or Rutherford. He was quiet, methodical, and more interested in the science than the spotlight. He published his findings in a series of papers, describing the phenomenon without fully understanding its implications. That task would fall to the Curies, who expanded on Becquerel's work, isolating radioactive elements like polonium and radium. For his discovery, Becquerel shared the 1903 Nobel Prize in Physics with Marie and Pierre Curie. It was a well-deserved honor, though his contributions are often overshadowed by the more dramatic achievements of the Curies and the scientists who followed. Yet, without Becquerel's accidental discovery, the entire field of nuclear physics might never have taken off. Radioactivity, as we now know, is the result of unstable atomic nuclei breaking down and releasing energy in the form of particles or electromagnetic waves. It's the process that powers the sun, enables carbon dating, and fuels nuclear reactors. It's also the basis for medical imaging techniques like PET scans, which have saved countless lives. But it's not all sunshine and roses. Radioactivity has a darker side, as seen in the devastating effects of nuclear weapons and the health risks posed by radiation exposure. Becquerel himself experienced some of these risks firsthand. While carrying a vial of radium in his pocket, he developed burns on his skin, an early indication of the dangers of radioactive materials. At the time, these risks weren't well understood, and many early researchers, including Marie Curie, suffered health problems from their exposure to radiation. Despite these challenges, Becquerel's discovery remains a cornerstone of modern science. His work demonstrated the power of curiosity and the importance of paying attention to unexpected results. It's a reminder that science isn't just about following a plan. It's about being open to surprises and willing to rethink your assumptions. Now for a few fun facts about Becquerel. Did you know that he was so modest that he initially downplayed his discovery, thinking it might not be significant? Also, there's an SI unit named after him, the Becquerel BQ, which measures the rate of radioactive decay. And here's a quirky twist. Becquerel's legacy is so deeply tied to radiation that his name often appears in safety protocols, where limits for radioactive exposure are measured in becquerels per kilogram. Henry Becquerel's story is a testament to the unpredictable nature of discovery. Sometimes, the greatest breakthroughs come not from bold experiments or grand theories, but from moments of serendipity and the curiosity to ask, what just happened here? So, the next time you hear about radiation, whether it's in a hospital, a power plant, or a sci-fi movie, remember the quiet Frenchman who left his uranium salts in a drawer and changed science forever.
Thanks for joining us. Get smarter daily by subscribing and liking. Grab the Ultimate 360 General Knowledge Smart Book to level up your wisdom. See you next time.